Imagine this, you're in a kitchen and you tell a robot, make me a snack. Sounds simple, right? But what exactly does that mean? A banana, a sandwich, a cookie. And what if the robot doesn't know where the ingredients are? Or if it's not sure if you want something sweet or savory? This is the problem of ambiguous instructions, a critical hurdle for robots trying to follow human commands in the real world. Enter AmbiK, a groundbreaking dataset designed to solve this exact challenge. Developed by researchers at LMU Munich, MIPT, and AIRI, AmbiK contains 2,000 tasks, 1,000 ambiguous and 1,000 clear, set in a kitchen environment. Why kitchens? Because they're a microcosm of real-world complexity, strange objects, multiple execution paths, and endless opportunities for misinterpretation. But here's the twist. AmbiK isn't just about making robots smarter. It's about teaching them when to ask for help. The dataset categorizes ambiguities into 3 core types. 1. Human preferences, like distinguishing between a crunchy snack and a soft one. 2. Common sense knowledge, understanding that boil water means heating it, not just pouring it. 3. Safety, recognizing that put the knife in the drawer might mean avoiding a dangerous mistake. So how did they create this? The team used large language models to generate ambiguous instructions, then had humans refine them. Each task includes the ambiguous command, a clear version, a clarifying question, e.g., do you want a sweet or savory snack, and a step-by-step plan. It's like a training manual for robots to learn when they're lost, and how to ask for guidance. But here's the kicker. Even top AI models struggle with AmbiK. Researchers tested methods like Conformal Prediction, a technique that quantifies uncertainty, to see if AI could identify when it was confused. The results? None of the models nailed it. Why? Real-world ambiguity isn't just about words. It's about context, culture, and human quirks. So what does this mean for the future? AmbiK isn't just a dataset, it's a roadmap. It shows that robots need more than smart algorithms. They need to understand when they don't understand. For researchers, it's a universal tool to compare ideas, pushing the field forward. Next time you hear about AI robots, remember, the real challenge isn't making them fast or strong. It's teaching them to listen and know when to ask, wait, what exactly do you mean? Thanks for watching and stay curious. Ever wondered how a robot knows whether to use a plastic or glass container for honey? Or why it might hesitate when told to fix the kitchen? Today, we're diving into AmbiK, a dataset helping AI systems tackle the messy, real-world challenge of ambiguity. Let's break it down. Imagine giving a robot a task like, fill the food storage container with honey. Sounds simple, but the robot doesn't know if you mean a plastic container, a glass jar, or even a metal can. That's where AmbiK shines. It pairs ambiguous tasks with clear ones, forcing AI to identify what's missing. For example, if the task is fill the glass container, the system checks if the AI mentions glass and avoids irrelevant details like oven mitts. It's like teaching AI to spot key clues in your instructions. But AmbiK doesn't stop at understanding tasks. It tracks user intent. Think of it as a checklist. Does the AI include the right words like glass and exclude the wrong ones like spoon? This helps measure how well AI grasps what truly matters in a command. Now here's where the science gets exciting. Researchers tested models like GPT-4 and Llama 2 to see how they handle ambiguity. They used Conformal Prediction, a safety net that lets AI say, hey, I'm not sure about this. Instead of guessing blindly, the system asks for clarification when uncertain. It's like a robot that knows when to pause and ask, which container should I use? The results? Some models, like GPT-4, excelled at recognizing when they needed help. Others, like Llama 2, struggled but improved with extra training. Metrics like intent coverage rate, how many key details the AI includes, and help rate, how often it asks for clarification, became the gold standard for evaluating performance. Why does this matter? As robots and AI take on roles in kitchens, hospitals, and factories, handling ambiguity isn't just handy, it's critical. A robot that asks the right question, instead of making a mistake, could save time, money, or even lives. Thanks for watching. If you'd like to explore more about how AI learns from ambiguity, hit subscribe. And drop a comment below. What's your most confusing task for a robot? Let's keep the conversation going.